All right, I want to show you briefly, for anyone who's been a little bit confused or not quite sure, how you can find and calculate the Splice donor and acceptor sites. So I've picked the RPS6 gene, which is a gene that a lot of you have. And I'm gonna pick the RB isoform because it has the 3 coding sequences, which makes it a little bit more challenging. So in terms of the Splice donor site, the Splice acceptor site for the first coding sequence, let's go ahead and zoom in. And remember, this gene is in the reverse orientation, so I'm going to click my arrow so it goes in reverse. Okay, perfect. I want to zoom in even more so that I can really see what I'm looking at. All right, so the gene or the coding sequence of this exon starts right here. It's in frame 2. So now I'm always focused on frame 2 because that's what the coding sequence is for this exon. So in frame 2, this is a really short exon. It's actually only 2 amino acids or 6 nucleotides. And so what I want to do, again, I'm focusing on the end of the coding sequence, and I'm looking at frame 2 only, frame 2. And what I see is that at the end of the exon, in frame 2, I have the end of a codon, right? I have a complete amino acid. In frame 2, I am not splitting an amino acid. So this is the donor site at the end of coding sequence 1. And so the donor phase is 0 because there are 0 nucleotides being left behind. Everybody is captured in a complete codon. Okay, so then I need to go to the beginning of exon 2. And because exon 1 is the acceptor phase, or sorry, the donor phase of exon 1 is 0, I know that the donor phase, the acceptor phase of exon 2 also has to be 0. And that's because when you add the donor of the previous exon to the acceptor of the next exon, it has to equal either 0 or 3. So if we're 0 over here, we're going to be 0 over here. So let's zoom in on this second exon. And remember, we are in the RB isoform. So just eyeballing this, I can already see that I'm not going to be in reading frame 1 because there's stop codons. I'm not going to be in reading frame 2 because there are stop codons. Reading frame 3 is probably my best bet. And in order to triple check that, I zoom in, and remember, I completed a codon with exon 1. So I should start a brand new codon with exon 2 at the beginning of reading frame 3. Because remember, 1 and 2 have stop codons, 3 had none, probably in 3, and I am because I have a full codon. I shouldn't have any stray nucleotides, and I don't. So then the acceptor phase for exon 2 is also 0 because there are no overhanging nucleotides. And 0 plus 0 equals 0, so that works with my math. So now we know that the second exon is in reading frame 3, and I'm going to go now to the back end of it. All right, so I'm in reading frame 3. Now I zoom in, and I'm trying to identify what is the donor site or the donor phase for reading frame 3. So what I see here in reading frame 3 is that I do now cut a codon. I leave 1 nucleotide here in the coding sequence, but I cut out 2 nucleotides as part of the intron. because there is one nucleotide left over, this single nucleotide left over, right? Because these two go with the intron. This donor phase is considered to be phase 1. There is one nucleotide left over. Now, just because I know how the math should work, if the donor phase of exon 2 is 1, the acceptor phase of codon or exon 3 has to be 2, because 1 plus 2 equals 3, and we'll make a full codon, a full amino acid. Okay, so the donor phase of exon 2 in this example is 1, because there is one nucleotide left over. So now I'm going to zoom out and go to exon 3.
Hey.
And that's Amelia. She says hi. Okay, so I'm going to scroll over to exon 3. Okay, here's exon 3. I want to look at the whole exon to kind of get an idea of what frame I'm probably in. And I can already see frame 1 has a stop codon right in the middle. Frame 2 has a stop codon right in the middle. So I have to be in frame 3. I'm going to zoom in at the beginning of frame 3. And what I hope to see at the beginning of frame 3 is that I should have an acceptor phase of 1, 2 nucleotides, because I have that single nucleotide left over in the donor phase of exon 2. And that's what I see. So I see that the acceptor phase here is 2, and that's great. Now, for the donor phase of this exon, it's nothing, because it's the end of the gene, right? There's going to be a stop codon. So I'll zoom out and just show that to you real quick so you know that I'm not lying. Okay, here's the stop codon in frame 3 at the end of the gene. So for the donor site for exon 3 in this case, you would just put an X. There is no donor site because it's not going to be splicing anymore. It's the end of the gene. So that's how you determine splice donor and acceptor sites.